Well, hey, Mark, one of the things that we've been talking about a lot lately is evolution in the world of computing. And you've told me that help's on the way. Would you be prepared to tell me a little bit about some of the things that you've been tracking and are interested in the world of new compute?
uh, when we talk about new compute, there's certainly things like silicon photonics that is out there. But today we're going to be diving into the wonderful world of quantum computing. So, quantum computers are a little bit different than classical computers. Classical computers using bits, quantum computers use qubits or quantum bits. And the idea being that a binary bit is a one or a zero, never the twain shall meet. Whereas quantum is, well, you're a one or a zero, or you're something in between. And it's this something in between squishiness of it that gives quantum computers their real power. So, one area that quantum computing is really getting a lot of traction and shows a ton of promise is in the area of optimization problems. So many things in our society require optimization, whether it's flight reservations or inventory control. Those are all optimization problems. It turns out that they fall into a type of problem. If you're a nerd out there, these are NP complete problems, but they're problems that are very, very hard. And when we get a number of coefficients that's even modestly big, it's going to require classical compute power that is longer than the life of the universe. And so for optimization problems, we use heuristics, shortcuts, rules of thumb, things like that. We never are guaranteed that we've got the optimal solution, but we can certainly look at two solutions and pick whichever one's better. Quantum computing, though, says, what if I could go ahead and solve a optimization problem? Then what that would do is it would collapse down the amount of time it would take to get that optimization, and it would guarantee that we had the optimal solution. So one can imagine if you had a great big complex equation, what if you could go ahead and represent all the possible combinations of all the possible coefficients in a massively long formula? And if I could ascertain that, all of the other values would fall into place, like some magic lens that lets you see next week's lottery numbers, right? So that's going to take thousands and thousands of qubits. And I think the record is rough and tough 64 right now. By the way, imagine someone talking about a 64 bits of memory. We're like in the 1960s era of quantum computing. But the expectation is we're going to be able to do this thing called quantum advantage. And that is when a quantum computer can solve a problem that a classical computer could not solve, regardless of how big it was and the life of the universe and time kind of thing.
So, if I summarize what you said, we're at the stage where we were able to use the von Neumann architecture and we were able to get people to the moon and figure out how to make rockets and spaceships. And then I guess as more capacity comes online, we'll start looking for other things. I can't even imagine what that stuff would be, but I wonder if random number generation might be one of the.
Tune in next week where we're going to dive into quantum key distribution, which one of the areas there is quantum random number distribution. By the way, there's a thing called entropy as a service. Boom, teaser. Tune in next week.